Hello everyone, welcome back to this channel. This channel now has grown to 137th episodes. So if you haven't subscribed this channel, well now it's time to do so, so you can access all those 130 plus videos uh, easily. So you can just by clicking the playlist. So don't miss that. So consider doing that. Subscribing, just click the bell button. All right, today we're going to show you how to do the vectors calculus question regarding force using vector calculus. So it's a simple question. So we're going to read the question first. These questions we got two. So there's a 2 kg, which is 2 kilograms of mass. So this is the mass, which is 2 kg. Initially rest a smooth horizontal surface. The mass act upon two another constant force. So we got two other forces. One is point on the right hand side. So that's the first one. The other first point on the left hand side. We're given the magnitude of force. One is 10 AN, 10 Newton. The other one's 5 Newton. So, question. So I also give you the angle with regards to the horizontal surface. So we need to find out the question one, what is normal reaction force? So normal reaction force, total normal reaction in newtons. Okay, so first we know the normal reaction force is equal to the m times by g, so which is gravity. So it's the opposite. So that's the diagram I'm going to use. So normal reaction means the object sitting on the surface, then the point on vertical up. So that's a normal. We call R. All right, so that's equal to 2g, but at the moment we got three collective normal reaction force. So we will need to put a resultant. So we put together the total normal reaction force, including R1, which is that one, R2, plus the R. So we got three forces together. The first R1 is easily to work out, which is 10 times by sine 60. Sorry, that's R2. My apology. So I should have put R2 first. Let's do R2 because otherwise confused everybody. So R doesn't matter which one for it. So plus. So R2 is the 10 sine 60. R1 is 5 sine 30 plus R. So we put them together. So the left-hand side is equal to 10. Obviously, work out the sine 60, sine 30, and work out it. R is 2g minus square root 5 square root 3 minus 5, 2 Newton. So that's question A solved. Pretty simple. Question B, find the acceleration of the mass if after it begins to move horizontally. So now this is the moving, obviously you can't go up, you're moving horizontally. So in the direction of, we don't know which way to do, whether it's towards the right or to the left. So we need to decide the first I need to decide the total resultant. We call RFR is m times by acceleration. So m is 2a, sorry. That's horizontal acceleration. So we call equation 1. Horizontally with the two other forces, F1, I'm using, because it's horizontal, I'm using cosine 60 times by 10, which is 5 Newton. F2 is 5 times by cosine 30, work out it's 5 square root 3 divided by 2. So those two compare. So F1, magnitude of F1 is greater than magnitude of F2. So therefore, the resultant force has to be F1 minus F2. So in the right direction. So we take it away and we work out equation number 2. So we combine equation 1 and 2 together. So we solve for A is 5 divided by 4 times bracket 2 minus square root 3 meters per square seconds. All right, question B solved. Now we're going to do question C. How far the mass travels in meters during the first 4 seconds. So let's do the integration first. We know the acceleration is according to question B. Then let's do the different. So we do integration VT. We found the VT is integration of 8. So we found out because of velocity initially was 0. So the answer C is 0. So the velocity function is 5 divided by 4 bracket 2 minus square root 3t. So now we find a distance. We call displacement, we call xt. So we're using 0 to 4, first to 4 seconds, from 0 to 4 of velocity, integration of velocity. So we put this one outside of that. So integrated t square, t become half t square. Substitute 0 and 4 into the equation. So the answer will be 16 divided by 8 is 225 is 10. So the answer is total distance of 10 times by 2 minus square root 3 meters. So that's question C. All right, that's it. That's a solve a vector calculus question regarding reaction, normal reaction force, and resultant, horizontal resultant force, and also the distance traveled. All right, so some people may think you can use another method number 2. So there's another, so that's method number 1. So if you want to use the other way to do is using the physics question. So we can use ut times by half of at square. So we can find a u is the velocity, initial velocity, and by plus the time, you can get the same result. But initial velocity obviously is 0, so that's the second way to do it. So I'm going to leave everybody to solve, and you'll get the same answer. I prefer the first method because we're using vector calculus instead of using physics question. So because it's a math. All right. Hopefully you enjoy the video, and please, if you do, give us the thumbs up, and I'll see you next video. Thank you.